Okay, today I'd like to discuss a little bit about some of the exceptions to Mendel's law of dominance. If you recall from our discussions that according to the law of dominance, anytime a dominant allele is present, it will always mask a recessive allele. You can see here I have big R for red and little r for white. If we were to talk about this in terms of flower color, using the normal Mendel law of dominance, if I took a purebred red flower with a purebred white flower, and I mated them together, I would get 100% of the F1 offspring to be red, but be heterozygous, meaning that they carry for white as well. Remember where these alleles are coming from. That would mean that one parent is going to have, for the gene for flower color, it is going to have big R, big R. The other parent is going to have chromosomes for that exact same trait to be little r, little r. So I'm putting one parent here and one parent here. This would be Mendelian genetics following Mendel's law of dominance, saying that anytime a dominant allele is present, it will express itself and mask the recessive allele. So all of these flowers in this offspring would be red, but they would carry for white. And you could also take two of these offspring, I'll take these two right here. If I mated them together using normal Mendelian genetics, you would expect 1 out of 4 to be red, 2 out of 4 to be heterozygous red, this one's homozygous red, and 1 out of 4 to be white. Now, this is Mendel's first law that says this is the way this should work. However, there are a couple exceptions to this law. So that's what I want to talk about today, are exceptions to Mendel's laws. And those two exceptions are called incomplete dominance and codominance. I'm going to first start out with incomplete dominance. So the word incomplete meaning obviously not complete. Dominance means to cover up, like in the last example I just gave, how red covers up white. So if something's to incompletely dominate something else, that means it's not going to completely mask it. And so what I'm going to do is I'm going to talk about flowers again. And in this particular situation, I'm going to talk about a flower that's called the 4 o'clock flower. And in this flower, the 4 o'clock, big R is going to be equal to red, little r is going to be equal to white. And we're going to do this Punnett square just like we did the last one. I'm going to say a purebred red plant with a purebred white. And in the last example, we saw that this is going to be 4 red plants. But in incomplete dominance, the red does not completely mask the white. And so big R, little r is actually pink. And this is where the term incomplete dominance comes from. The white is allowed to express itself a little bit, and so you merge the colors of red and white together to get the pink. How could I get red and white flowers back if I lost these plants? I could take 2 of the F1 generation, which are these guys that are all pink now, and if I took 2 pink flowers and mated them together, 1 out of 4 is going to be purebred red again, 2 out of 4 is still going to be pink, and 1 out of 4 is going to be white. This is incomplete dominance is what this is called. The other exception to Mendel's law of dominance is what we call codominance. An example I'm going to use with this is a horse that's called a roan horse. A roan horse is one that has 2 different colors of hair, usually like a reddish brown color and a white hair. If you were to grab a handful of the horse's hair, you would see that some of the fibers were red and some were white. They're not a merger of 2 colors like incomplete dominance. These are actually 2 separate colors. And so what we're going to do is we're going to say that big R equals the reddish brown horse. And we're going to say that big R prime is a white horse. Notice I did not use any lowercase letters because there is nothing here that is recessive. I'm going to take a purebred red horse with a purebred white horse, and 100% of the offspring are going to be what we call roan. This is where both of these dominant alleles are present, and that means that that horse will have hairs of both different colors. So say we take out these parents, the P generation is gone. I can take this F1 generation and mate 2 of them, and that's going to be, these are both roan horses that are mating. And if I mate 2 roans, 1 out of 4 of their offspring should be red, 1 out of 4 should be white, and 2 out of 4 will still be roan. And this is called codominance.